In this example, our data is starting out low and giving us a higher output. So we're in the realm of addition or multiplication. In this case, it looks as though we might have to add 2. And that certainly works. If you input 2 plus 2, you would get 4. But it totally breaks down when we go to the next box. That only gives us 8, and we have 36 here. So there must be a different relationship. It's not addition. Maybe that's multiplication. Let's try that. Multiply by 2. Well, 2 times 2 is also 4. That's good. 6 times 2 is, 12. So it's not an addition or multiplication. There is something else going on with this set of data. But it still needs to be thought of within the realm of operations of addition or multiplication. Okay, so we've got 4 and 36, 64, 81. Those are the doubled numbers that we studied when we were learning our multiplication tables. Aren't you glad you spent so much time learning those? Here it is again. How did we get to 6 and 36? What is the relationship with that? Well, if we went 6 times itself, or 2 times itself, 8 times itself is 36, 4, 64. So really what we've done was we've taken the x term and we've squared it. It's square first term. So if we have 8 into our machine and then we square it, we will get an output of 64. Let's try that for our 6. If we put a 6 in and square it, it comes out as 36. Now that we've got these to work with our idea of squaring the first term, we now can take our 81, that's our answer. What times itself is 81? 9 squared. And if we don't know if it gets higher, and we're not really sure of what it is, let's say we've got 144. That wasn't in our multiplication drills when we were learning those. So we would have to take, let's do this one. 9 squared is equal to 81, but you can also say that the square root of 81 is equal to 9. So if we were to take the square root of 144, we would now get our x. And our square root of 144, let's put that one back up here. Remember, we're factoring this. This is an even number, so we already know that 2 will work in this. 2 goes into 144 72 times. That's prime. Let's try this. 72 is 8 times 9. But those are not prime numbers. We can still keep going. 2 times 4, prime. 2 times 2. And our 9 is 3 times 3. Now we're going to apply our rules for the roots and look for pairs of numbers that make whole. A pair of 2's comes outside this radical sign as a 2. Here's another pair of 2. These are factors, so I'm multiplying them. And a pair of 3's gives us 3. Now we can multiply these together. 2 times 2 is 4. 4 times 3 is 12. So 12 is our answer. If we took it back to our machine and said our input is 12, would our output be 144? Well, 12 times 12 is 144.